Hi everyone, welcome to Vedantu NEET English. I'm Diksha Ma'am, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to all of you or not, so that we can start with this very important lecture of Bohr model and hydrogen spectrum. Now, the question is that, ma'am, how many questions I can expect from this particular topic, not even chapter I am saying. See, from this chapter, two topics are extremely important. That is Bohr model, hydrogen spectrum, that comes under one roof only. And if you talk about quantum numbers, right, that is the next important topic, right? So they are very frequently asked. From here, direct formula based questions can be asked to you. No tricky questions are there. Very direct formula based question. And 2025, right, they have asked one question from this, not one. I am just telling you that that question is where simple energy and radius formula you need to apply, and direct answer you can calculate, but the calculations, every option you have to solve. That was the main thing, right? So otherwise it was a direct question only from the formulas, right? So what you need to understand here is how to apply the formula, practice of questions. So that's why I'll be picking up the previous year questions from your NEET and latest NEET papers I'll be picking up, right? So everybody, do let me know in the chat box if you are ready for the class or not. Yes, everyone. Okay. So full focus here, right? Okay. So let's start this, right? So starting with this thing, right? We know that we have already talked about what is EM waves, what is simple absorption emission spectrum, that we have already talked about in the yesterday's lecture, right? So now today we are going to talk about Bohr model, right? We know that in Rutherford model we discussed that electron is revolving. Now the electron, is it revolving in some discrete orbits, right? Is there some distance from the nucleus where the electron is revolving, right? This is what Bohr is going to tell us, right? In the last lecture, we discussed about Planck's quantum theory, right? We also discussed that how in black body radiations you have Planck's quantum theory, right? Now in Planck's quantum theory and also photoelectric effect in black body radiations, they were the proofs that the electromagnetic radiation is existing as a particle also, right? So whenever I talk about that it is existing as a particle, that means we discuss that E is equals to h mu. This is what we discussed, that yes, electromagnetic radiations, like we have electron, they actually possess particle nature as well, right? Now, based on this particle nature, right, Bohr made his model. He said that like you are saying quantum, everything is existing in quanta, right, in packets. He said that in the similar pattern, right, let's say this is nucleus, and he said that this is the, what are these? These are the orbits. And what he said that this is, let's say n is equals to 1, this is n is equals to 2. He said that it's not like electrons are revolving randomly, right? It's like we all are living in homes, right? We are not living on roads, right? So the one who are living on roads, that is random, right? We have discrete home. Okay, this is my house. This area belongs to me, right? That is your house. This room belongs to me. This chair belongs to me, right? Similarly, electrons have their discrete orbits in which they are revolving. Electron cannot revolve here, cannot. Yes, it can revolve in this particular area, in this particular area, in this particular area, in this particular area. And you know what? These orbits that he is talking about, Rutherford said that he didn't tell you anything about that there is some radius, there is some fixed distance, but Bohr told you that there is some fixed distance, right? From this fixed distance, this particular electron is revolving, right? So this is N1 is also at a fixed distance, N2 is also at a fixed distance, N3 is also at a fixed distance, N4 is also at a fixed distance, N5 is also at a fixed distance. Okay, got it everybody? There is a fixed distance, right? And that we define as radius. That n is equals to 1, what is the fixed distance? N is equals to 2, what is the fixed distance? That is defined as radius. What is radius in a circle? The center point, right? If I draw a circle here, this center point and this distance is the radius. So similarly, in this case, any orbit you talk about, right, that will have a proper distance from the nucleus, and that is called as the radius. Now, that radius depends upon the atom that you have, right? That depends upon the orbit that you have. N is equals to 1, 2, 3, 4. What is that orbit? Okay, got it everybody? Right? Now, let's talk about the next thing, that is, let's not erase this. I'll just copy paste this. Now, tell me one thing. If you talk about Bohr model, this is applied not to every atom, right? This is only applied to what kind of species? Anybody in the chat box? What kind of species? What kind of atoms this is applied? This is applied to only single electron species. Single electron species. That means hydrogen or hydrogen-like atoms. Now, hydrogen has 1 electron. Helium positive has 1 electron. Lithium 2 positive has 1 electron. So, if you talk about beryllium, 3 positive has 1 electron, right? So, all these 3, because helium has 2 electrons, 2 protons, right? When you take out 1 electron, it will become helium positive. So, it will be 1 electron, 2 proton, right? Similarly, in case of lithium, hydrogen, helium, lithium, that is, you have 3 electrons, 3 proton. You take out 2 electrons, it will become 1 electron. Similarly, in case of beryllium, you have 4 electrons and 4 protons. Neutrons here I am not talking about. Neutrons will be same as the protons in almost all of the cases. Right? This is, you take out 3 electrons, it will become 1 electron, 4 protons. Can you see that over here? Right? And that's how they all are single electron species. So this Bohr model is not applied on the multi-electron system, and it will also become the drawback of this particular model. Right? Now, let's discuss what is written here. Niels Bohr in 1913 was the first to explain quantitatively, quanta, right? Packets it is existing. He gave you discrete values here, right? The general feature of the structure of hydrogen atom and its spectrum, right? So, let's talk about the postulates here. The first postulate, guys, that is, postulates are extremely important. On each postulate, you will see there will be previous year questions only I am going to teach, and you will see in latest how they are asking the questions, right? So, physical chemistry is not done without question practice. So, that's why I have tried to take every single kind of previous year questions that they are asking, right? So, we will also go beyond PYQs, what they can ask you now in 2026, right? So, first postulate is the electron in the hydrogen atom can move around the nucleus in a circular path of fixed radius and energy. Now, he said that they are moving in a circular path with fixed energy, with fixed radius, fixed velocity. Everything is fixed, right? Then these paths are called orbits, right? These circular paths are called orbits. Stationary states or allowed states. Allowed means you can only travel here, right? There are some rules, no parking, right? There is parking you can do here. So allowed states, that here only you can reside, anywhere else you can't reside, okay? So stationary states or allowed states, the orbits are arranged concentrically around the nucleus. So he said that this is the nucleus, this is the nucleus. He said that this is the nucleus, and concentrically means this is n is equals to 1, this is n is equals to 2, this is n is equals to 3, and so on it will be. Okay, this is what he told you, right? Now, let's talk about, ma'am, what he gave us. Ma'am, is the radius derivation important, velocity derivation important? Not at all, right? These derivations are not at all important when it comes to competitive exams, right? Okay, so what we are going to discuss is simple, what is the formula in the end, right? Formula should be on your tips, right? Formula and formula application should be on your tips. So radius is dependent on the orbit number and the atomic number. Okay. So this is going to be, let's write it, 52.9 n square by z picometer. Right? Okay, everybody. Now, what is going to be the value in Armstrong? Anybody in the chat box who can tell me? Anybody in the chat box who can tell me? Anyone of you? So, let's see. If you convert this into, nanometer, or let's convert it into Armstrong, okay? 0.529 n square by z, right? That is in Armstrong, right? And you know what? You can also write it directly that radius is actually directly proportional to n square by z, right? Radius is directly proportional to, because based on this also they ask you the question. Now it is also written in the same format. It is also written like this: Rn is equals to A naught n square by z, where A naught is 0.529 in Armstrong, or A naught can also be 52.9 in picometer. Now it depends that what they are asking you. Are they asking you in nanometer, picometer, Armstrong? Usually they ask in these three parameters only, or centimeter as well, but usually they ask in picometer, Armstrong, or nanometer, right? Now, these are the equations that you have to remember. You can remember one of them, that would be great, okay? So I would advise you to remember only this one, because this particular thing has everything, right, that you need, right? So everybody repeat after me. If you're alone in your room, just speak it loud, right? Rn equals to A naught n square by z. A naught n square by z. That should be in your head, right? Okay. Now let's talk about the questions, right? What kind of questions they ask you? Let's talk about NEET 2022 question that they asked you based on this. If radius of second Bohr orbit of helium positive ion is this, right? They told that radius of second Bohr orbit, that means, can I say n is equals to 2 here? Students, can I say n is equals to 2 here? Yes. Of the helium positive ion, hydrogen helium, that means Z value will be equals to 2. Because students, it is depending upon n and z, where n is the orbit number and z is the atomic number, right? For hydrogen, let's say you can write it here. For hydrogen, z is equals to 1. For helium positive, z is equals to 2. For lithium 2 positive, z is equals to 3. For beryllium 3 positive, z is equals to 4. Now, that is the whole scenario, right? Now, if you see this, it is going to be z is equals to 2 is 105.8 picometer. What is the radius of third orbit of lithium 2 positive with that respect? Okay, so you can solve it in two ways. Either you can directly say radius, either you can directly write here that what is the radius? You can directly write radius is equals to, if they ask in picometer, that will be 52.9 n square by z. Okay, what is n square? That is 4. So I can write it as 52.9, right? N square is what? N square is 2 square divided by 2. So you can see Rn is nothing, 52.9 multiplied by 2, right? Are you getting the same amount that is written here? Yes, somewhat similar we are getting. Okay, we are getting the same amount. Now, let's understand they have given you that this Rn is coming out to be 105.8. They are assuming that you don't know the formula, right? We can directly calculate what is the radius of third orbit, because without this information also we can answer this. We don't need to write down this information. What is the radius of third Bohr orbit? So n is equals to 3, right? Lithium is what? Hydrogen, helium, lithium, right? Hydrogen, helium, lithium. So can I say here Z is equals to 3. So Rn is going to be for lithium 2 positive, right? Lithium 2 positive, it is going to be 52.9. N square is what? 3 square by 3, right? Okay. So this will be multiplied by 3. Okay. Is it third Bohr orbit of lithium? Yes. Now you need to add this 3 times. You can also do one thing. 105.8 added 52.9. You will have 8 to 16, 17, 5, 6, 7, 8, 158.7. 158.7 picometer. Directly you can say, you can directly calculate this here. You don't even need to apply this and calculate this. It's totally your choice how you want to calculate this. See, if I would have been at your place, I would have not choose this. Okay, I would have just, this is the formula, this is what I can use here, right? Directly I can calculate the value that is coming out to be 158.7 picometer. So answer is going to be A is the correct answer. Directly, this is an unnecessary information that they have provided, right? If you know the formula, you don't need this information. Okay, right? So answer is going to be A is the correct answer. You can directly solve it here, right? Now, the other method that I asked you, that this way also you can use, but you don't need to complicate it, right? Complication is not needed here, right? So other method is, if you directly say radius is directly proportional to n square by z, right? We know that for lithium, n square, n is 3, z is 3. For helium, n is 2, z is 2, right? So you can just solve it here. This value you know, this value you can say, but can you see that this method is getting complicated as compared to this method here, right? Okay, but yes. Let's say, let's take an example. They give you, now I'm taking another example here, right? If they give you this kind of question, I would not advise you to solve it like this. I would advise you to solve it like this only. But what if they give you a question in which they have not given some value here, right? They are, for example, saying you have helium positive where n is equals to 2, right? N is equals to 2. Radius is coming out to be x. Okay? Radius is coming out to be, let's say, x. Okay? Or you can take it as radius is coming out to be x only, right? You have lithium 2 positive where n is equals to 3. Now radius will be what? In terms of x, right? Now they have asked you in terms of x, you have to answer. Now in this kind of situation, I have to apply the ratio, okay? Because I have to answer it in terms of x, right? Now what you will do, guys, now let's answer this, okay? This is a question that is given to you. Answer how you will solve. Firstly, the question is clear now. If they have given you this information and this information, there is no need, because directly by applying the formula, you will get the correct answer, right? So that information is unnecessary. But what if they give you this is x, some random value they have given you, right? Now what you will do? In terms of x, if you have to answer, what I'll do here, we know that radius is equals to, let's talk about it in picometer, 52.9 n square by z, right? Or rather, I would write it as a naught n square by z, okay? Or you can also write it as Rn is directly proportional to n square by z. So, for radius of helium positive, it is directly proportional to what is n for helium? N for helium is given to be 2. 2 square by Z is 2. So it is going to be directly, you can also write it as this. This is A naught. You can write it as A naught 2. So you can write it as 2 into A naught. Right? Now radius for lithium 2 positive is going to be what? Everyone in the chat box, tell me if that is clear, right? Okay, that is getting clear to everybody, right? Now, lithium 2 positive, guys, what is the value of N here? They have given you third orbit. Okay, so A naught 3 square. What is the value of Z in lithium? Hydrogen, helium, lithium. Lithium is 3. So I'll write it 3, right? So it is coming out to be 3A naught. Right? Now I'll take the ratio. This is, let's say 1. This is, let's say 2. Now I am taking the ratio. That is what I need to calculate. They are asking you for lithium. So radius for lithium 2 positive divided by radius for helium positive is going to be, this is for lithium, it is going to be 2A naught, right? For lithium, it is coming out to be 3A naught and this is coming out to be 2A naught, right? This will cancel out and we know that radius of lithium 2 positive is nothing but 3 by 2 of radius of helium positive. Now, radius of lithium 2 positive is nothing but 3 by 2. Radius of helium is nothing, that is coming out to be x. So now we have solved the answer of radius of lithium in terms of x. Okay, in terms of x we have solved it, right? Got it, everybody? Got it what we are doing here? See, again I am repeating for all the students who have confusion in this. What if they give you comparison or directly they ask you the radius? Directly apply the formula, you don't need to take any ratio here, right? But what if you have this kind of question, right, where you have to solve other radius in terms of something else? Or they can even ask you in the question, what is the ratio of, let's say they have given you helium is this, lithium is this, what is the ratio of helium and lithium? Same method you will apply. What you will apply? Firstly, radius of this particular species, radius of other species, right? Then you take the ratio. A naught you will put here, not 52.9. Why I'm saying you can put 52.9 also. Is that you will have to write it again and again, right? So it's better to write it this way. You take the ratio, you will have your answer here. That's how you can solve the questions of radius, right, based on the direct and inverse proportionality, right? Okay, guys, is that clear? Now, next question is of velocity. Now, radius and velocity, the kind of questions they ask you is same, but till now they are asking more questions of radius, but I feel that now they will start asking for velocity as well. So what is the value of velocity, everybody? Everybody. See, in radius it is n square by z. Here it will be opposite, that is z by n. Right? And what is the value? 2.18 into 10 raised to power 6 z by n meter per second. That is the formula that you need to remember. Okay? That is the formula that you need to remember for this. Right? Okay? Now, see what I am going to tell you here. If they ask you, similar way, they are saying velocity for helium positive, take the velocity for lithium 2 positive, what you will answer here? Anybody in the chat box, what you will answer here? If they ask you velocity of helium positive divided by velocity of lithium 2 positive, and they are saying that question is that helium positive is existing in n is equals to 4 and lithium 2 positive is existing in n is equals to 4. N is equals to 5, let's say. Random example I am taking. Now what you will apply? You will apply the same formula, but we know that whenever we take the ratio, we just directly write the proportionalities. This is z by n. So what you will say? Z by n of helium positive, Z by N of lithium 2 positive. Now, if you write this here, Z of helium is what? Z of helium is 2 divided by N of helium is 4. Z of lithium is what? Hydrogen, helium, lithium. Lithium is 3. Students, Z is nothing but that is the atomic number. Okay, hydrogen, helium, lithium. Right? Now, what is this N here? What is N, everybody in the chat box? What is N for lithium? Isn't it given? N will be given in the question itself, right? N is given to be 5, right? So can I solve it here, everyone? 2, 2. So it is coming out to be 5 by 6 is the ratio, right? Can they ask same kind of question in radius? Yes. They can ask you find the ratio of radius. You will apply the same method, same thing in radius. You will say it will be directly proportional to n square by z. According to that, you will use the ratio. Now, can they ask you in velocity the same kind of question that we have done for radius? For example, they give you for helium, this is orbit number. For lithium, this is orbit number. Now, calculate the velocity. Can I do this similar in case of velocity also? Can I do this similar in case of velocity also, guys? Let's do it. Okay, let's do it. What is velocity? Okay, let's solve this. Let's say they have given you not this, but they have given you velocity. Velocity of helium positive. This is velocity of lithium 2 positive. Okay. Now, if you see this here, students, be very, this is very interesting, okay, and very simple. Helium positive, N is equals to 2. What is velocity? Velocity is directly proportional to Z by N, isn't it? So can I say velocity of helium positive is, you can say, okay, let's talk about this thing. You can say what we are calculating, velocity of lithium. So what we are calculating will be in the numerator here, right? So velocity of helium positive, right, is equal to Z by N because it is directly proportional. So it will be lithium 2 positive. And here it will be Z by N inversely. So here it will be Z, inverse will be N of helium. Right? For lithium, it is directly proportional. For helium, it is directly proportional. Right? Now, if you apply this, what is the velocity here? What is the velocity of lithium 2 positive is equals to, okay, let's do this like what we have here. This is going to be, what is Z for lithium 2 positive? Z for lithium 2 positive, we know that Z is equals to 3, here Z is equals to 2. So it is going to be 3 and this is also 3, right? For helium, this is 2 and this is also 2. Can I say it is cancelling? Now this is lithium 2 positive, this is velocity of helium 2 positive, helium positive. Can you see that velocity of lithium 2 positive is coming out to be same for helium positive? So we can say velocity of lithium 2 positive is equals to x only, right? Okay. Can you see that how we identified this thing with simple one formula? These many variety of questions they can ask you with direct formula also they can ask you. This is the ratio kind of thing that I told you. Directly also they can ask you for beryllium 3 positive. Okay, one more question I will write here. Based on this, they can also ask one more kind of question, that is, see, I am telling you all the kind of questions that they can ask you, right? Because it's about variety, you should know, right? So one more kind of question that they can ask you is, guys, please focus here, right? Okay, please focus here rather than, I would also want you to participate, but it's not like you are chit-chatting or you're not focusing on what I'm teaching you, because this is very important, right? So please be focused, be disciplined in the class, right? So question is that you have Z and N here. So simply what you will see, they can ask you velocity of beryllium 3 positive in second excited, or they can say first excited state. Okay, in first excited state. They can also ask you in second excited state, right? See, if you talk about first excited state, second excited state, what you have to do, they are asking you the excited state. Okay, so in first excited state, you will say that means 1 plus 1 is 2. Okay, excited means if it was here, by getting excited one time, it will be in the plus 1 zone, right? Second excited state will be here. From this, it is traveling to this side to this side. That means you will add 2 there. Okay, so second excited state is 3, first excited state is 2, third excited state will be 4. Okay, that way you have. So first excited state is nothing but N is equals to 2. For beryllium, you have Z is equals to 3 or 4. It is 4, right? Hydrogen, helium, lithium, beryllium. It is Z is equals to 4. Now, velocity will be simple, 2.18 into 10 raised to power 6 into Z by N. What is Z? Z is 4, N is 2, 2 into 2. So, answer will be 4.16. Wait a minute. 16, 4.36. Okay, 4.36 into 10 raised to power 6 is going to be your answer here. Okay, yes everybody, so directly they can ask you the questions, right? Now statement based questions that they can ask you. Two statements are given to you. You have to answer which of the following is correct. So first statement is, according to Bohr model of an atom, qualitatively the magnitude of velocity of electron increases with decrease in positive charge. They are saying, according to Bohr model of an atom, qualitatively magnitude of velocity increases with decrease in the positive charge in the nucleus, as there is no strong on electron by the nucleus. Now they are saying, as you go beyond, apart from the nucleus, the velocity will start increasing, right? Okay, magnitude of velocity increases, okay, with decrease in the positive charges on the nucleus, right? Okay, so we know that velocity is equals to minus 1.8 Z by N, right? Magnitude will be dependent upon Z and N, right? So as your positive charge is on the nucleus, right? Wait a minute. The magnitude of the velocity increases with decrease in positive charge on the nucleus. Decrease in positive charge. Positive charge decrease means they are talking about that if you talk about hydrogen, helium, positive charge on the nucleus. Okay, so hydrogen has 1 proton, helium has 2 proton, lithium has 3 proton, right? That means according to Z, as Z will increase, as Z is going to decrease, the velocity magnitude is also going to decrease, right? So can we say this statement is not going to be correct, right? Okay, so that is directly proportional. This atomic number of an atom corresponds to positive charge. Okay, so as Z will increase, this will increase. As Z will decrease, this will decrease, right? So first statement is going to be wrong, right? So this is what they are talking about. Next is, according to Bohr model of an atom, qualitatively the magnitude of velocity of electron increases with decrease in principal quantum number. Now that is directly proportional to Z by N. When you decrease this, this is going to increase, right? Velocity will increase with decrease in this, that is true. Okay, so first statement is false, the second statement is true. So can I say out of this, first statement is false, but second is true. So we can say that C is the correct statement here. Right? Okay, everybody. Clear? If that is clear, do let me know in the chat box, everyone. Okay? Any problem till here? Any problem till here? Yes, everybody. So, let's talk about energy. So, here we are talking about total energy, right? So, in the similar way, he calculated about energy as well. So, energy formula is coming out to be E is equals to, first thing is E is directly proportional to which thing? Everybody in the chat box? Yes. Here we talked about in radius it was directly proportional to which? Velocity it was directly proportional, energy it is directly proportional to what? See, in velocity it was coming out to be z by n, it was n square by z, right? Okay. Now, we have velocity, just you need to square this. Okay, everybody? This is velocity, you just need to square this here. This is n by z. Velocity and energy is opposite, that is z by n. Velocity is simple z by n and energy is z square by n square. That is the difference here. Okay? Yes. So that means it is directly proportional to z square by n square. Firstly, this thing you should know. Next is the formulas that are in different units. Okay? Minus 13.6 z square by n square electron volt per atom, right? Now, minus 2.18 into 10 raised to power minus 18 z square by n square joule per atom. Okay, minus 1312 z square by n square kilojoule per mole. So these are the three formulas that you have here. Okay, everybody, clear? These are the three formulas that you need to learn as it is. See, there will be very less time for conversions in the exam. These are the mostly asked units that they ask you: electron volt per atom, joule per atom. If they ask you kilojoule per atom, you can easily convert this, right? Now, if this they ask you in kilojoule per mole, this is the formula. If they ask you in joule per mole, you can easily convert this, right? Okay, so these are the three formulas to remember for energy, right, everybody? Ma'am, do we have to remember this? Yes, you have to remember this. Don't worry, I have also made this particular chart for you guys. You just have to remember whatever is written here, right? So, radius, right, then velocity, then you have energy. This I have written here, right? One more formula of energy we can add it over here, that is minus 1312 z square by n square. This is kilojoule per mole. Okay, this is per atom and this is also per atom. Okay, so all are the formulas that you should remember, right? Now I know that you are thinking about this time period. Don't worry, we are going to be there, right? So firstly, let's understand more about energy, right? Now, very rare chances that they will ask you kinetic and potential energy, like specially, but still if they ask you, you should know, right? So if they ask you total energy and kinetic energy and potential energy, directly learn the relationship here, right? So if you talk about total energy, that is coming out to be x. If I say that total energy is minus x by 2, then kinetic energy is opposite of that. Now, some students also learn it this way, that if I say total energy is x, or let's say minus of x, kinetic energy is going to be x. That is opposite of that. And potential energy is going to be double of it. So you can say potential energy is equals to minus of 2x. If you don't want to remember this, you can skip this, right? That's totally your choice, right? You can skip this particular thing, right? Because x by 2 is difficult to remember. This one will be easy for you to remember, right? What is this? Total energy and kinetic energy, there is just change in sign, okay? And if you talk about potential energy, that is double of the total energy with the same sign, okay? If I say total energy is minus x, then kinetic energy will be x and potential will be minus of 2x, right? Now, talking about ionization energy. Now, students, this ionization energy, you must have heard about this in periodic classification that we will study, don't worry. Ionization enthalpy, ionization energies, you have, this is the atom, right? This is the electron. The energy to take out this electron, energy required to take out this electron from this particular atom, that is ionization energy, okay? And it is opposite of your energy here, right? It is opposite in sign, right? Okay. Yes, everybody. Okay, so that was about the energies. Now let's understand the kind of questions that they have been asking you here. First question is for NEET 2024. First question, guys, is for NEET 2024. So everybody, are you ready for the question? Are you ready, everybody? Are you ready? Am I fast? Am I fast or am I going? I'm trying my best to be on a right pace so that none of you feel that your time is being wasted, because I know that time is precious for you, right? And that's why I'm not chit-chatting with you guys, right? So I just want that every single minute that you're investing on this channel is fruitful for you, right? That is the only aim that I have, right? And that's the reason, right, I am like less interacting with you, okay? Yes, everybody, but you need to interact. You need to tell me, okay? And stop spamming, right? I know you are like, you want to understand things, but please don't spam, okay? Yes. So let's see this here, NEET 2024, NEET 2024. The energy of the electron in the ground state for helium positive is minus x joule. Then for the electron in the state of this will be what? Okay, in joule. Joule they are saying. Okay, fine, no issues. See, if I say the energy of the electron in ground state for helium positive. Now, can you tell me for helium positive Z is equals to 2? For beryllium Z is equals to 4. I think they are going to be equal, but let's see, right? So we know that energy is what you will do. Everybody, what we will do here, everybody, we will take the ratio. When, can't you see it is on the same page, same thing for radius we did. For this it is x, find for this velocity, for this it is x, find for next one. It is in the same page that we discussed, right? So that's what I am telling you. Formulas of velocity, radius, energy might change, but the way of asking the questions is same. Either direct formula or taking the ratio. That is only two cases they can ask you the question. Okay. So now what you will do here is, you will say that, I'll just take one line, just separate this. We know that energy is directly proportional to z square by n. I think it is going to be same only, because for velocity also it occur to be same, because they will cancel with each other eventually, right? But let's talk about this, right? Now we'll take what we are trying to find out, energy of beryllium 3 positive and energy of helium positive, right? That is equals to z by n square, okay, or what you can say, z square by n square of beryllium 3 positive. What is this? Here direct proportionality is z square by n square. This is for helium positive, isn't it? Now, what we are going to do, z is 2, n is 1. So, shall I put it here? Yes, ma'am. Right? Z is going to be 2 here. This is going to be 1 here. And you take out the square. This is going to be, okay, whatever is there, don't worry about that. Right? So now here it is going to be for helium, it is for beryllium we will find out now. For beryllium it is Z is equals to 4. So it is going to be 4 square. You can also write it as 4 by, what is this, 2 whole square. See, Z square by N square, you can write Z by N whole square, right? So here you can write N by Z whole square. Here N is 1, Z is 2 whole square, right? For beryllium, we don't know. And very good, very good. Students, write it down in the chat box. What is the answer? For this, they have given -x. Okay. Now, can you see this will cancel out as 2? So here answer will be energy of beryllium 3 positive is going to be 2 square. Here also it is 2 square. It will cancel out. This is energy, that is -x. So energy of beryllium 3 positive is going to be -x. That is E is going to be the correct answer. Tell me, was it a difficult one? Was it a difficult one? No, it was easy peasy. It was easy peasy, guys. And what they have asked you in 2024. So easy peasy question from Bohr atomic model, right? Okay. So this you don't have to do. You don't have to solve it, guys. You don't have to solve it, right? This is a lengthy method. This is a simple method of solving it, right? The simple method is direct method. Okay, that is a lengthy method. So we are going to see as simple as we can make it. Now, this is a question of NEET 2025, right? That we are saying is tough exam. Now, why students find it tough? Can you see in NEET 2024 what kind of question they have asked you? Just in few seconds you can do it, right? Now in NEET 2025, in chemistry what happened is that they gave you lengthy questions, right? There are 180 questions for 180 minutes, right? So we know that the weak point of NEET aspirant is calculations, right? And this is what they gave you here. By looking at these calculations only, students got scared, right? Okay. 4 total calculation, 4 formula calculations were needed here, right? So what we'll do here is, firstly, we will solve the radius. See, radius here is different, radius here is different, radius here is same or different. In these two cases, it is same. So I am telling you how to solve it in the exam, okay? Radius here is different. See, most probably B and D will be cancelled, okay? Most probably it will be like that. See, if you are able to solve 3 calculation, even if you do that, then also it will be great. Now I'll tell you how to do it, right? Okay. If you are able to solve for lithium radius, solve for helium radius, then any energy you solve, either for this or for this. See, energy is same here. Wait a minute. Isn't it the same thing? No, it is not same. This is 10 raised to 18, this is 10 raised to 18, this is 10 raised to 16, this is 10 raised to 16. See, by looking at the formulas, by looking at the options, if I would have been at your place, I would have already eliminated these two. See, sometimes in the exam, I'm telling you a trick for the exam also, how to do guesswork. We are very intelligently doing the guesswork, right? We know that even if you solve the ratio of lithium to positive and helium positive, we know that R is directly proportional to N square by Z, right? If we are saying that radius of first Bohr orbit of this and this, N is same, that means N is same, guys. N is same. Such a brilliant thing here, right? They are saying N is same. N is same means it is inversely proportional to Z. Now, Z for lithium and helium is different. It's not possible that they will be same. So, this option is already eliminated. We don't need to solve the radius. Even if you're able to solve radius of only lithium, still we have to be sure. Maybe they are playing with you. Maybe this is the correct answer. So, just solve the radius of lithium. If it is, this will surely be 17.6. Because in both the options, you are getting this. They want to confuse you. See, there is slight change that they have done. So if I would have been at your place, I would have done just one calculation. That is, I would have solved only energy of helium. I would have solved only the energy of helium. That's it. And that would have given me my answer. Right? So let's see this. Right? Let's see this. Now, guys, if you see, let's solve what you want to solve. I would focus on radius of helium-2 positive and energy of helium, right? So radius of helium, can you see they have asked me in, see, this is already eliminated. I am just doing so that you don't think that ma'am is doing guesswork, right? So picometer, we just have to solve, right? So that is 52.9 for helium first orbit. So that means n is 1. Z is what? 2. So it is going to be half of it, right? And half of it, can I say that 52, half of 52.9 is nothing but that is 2. This is 6.4 something, right? 26.4. Can't I see such an easy calculation? That means this is also eliminated. Do I need to solve lithium? No, I don't need to solve it, right? Now, which energy would you want to solve? I would solve for helium, right? So helium energy is 2.18 into 10 raised to power minus 18, right? What is Z? What is Z, guys? Z square by n square. What is Z? See, n is given to be 1. Already they have given it to be 4. N is equals to 1, right? Z is for helium, it is 2, so it will be 2 square. So 2.18 multiplied by 4, right? That is going to be 24, 4, 5, 7, 4, 8, 8.72 multiplied by 10 raised to power minus 18. 8.72 multiplied by 10 raised to power minus 18. We can see C is the correct answer, right? So if I would have been at your place, I would have directly eliminated this and solved just energy of helium, and your answer is there, right? So you have to see the questions very smartly, right? And then easily you will be able to answer this, right? You don't need to solve for every single option, right? That you don't need actually, right, students? Okay, shall we move ahead? Based on the equation, now they are saying that based on this equation, certain conclusions are written. Which of them is not correct? Right? Certain conclusions are written here. Larger the value of, larger will be the radius of orbit. Which value is larger? I think they are asking, actually here it was Z, okay? Larger the value of Z, larger will be the radius of the orbit or not. Based on this equation, they have given you. See, there is some confusion with the question. They would have also given Rn is equals to A0 or 52.9, or directly you can say A0 n square by Z. Larger the value of n, larger will be the radius. This is actually the real statement here, okay? This is the statement that was given in the question. Larger the value of n, larger will be the radius. See, more the value of n, more will be the radius. That is true. So we can say this actually is true. The equation can be helpful in calculating the change in energy when the electron varies its orbit, right? When this equation can be helpful in calculating the change in energy, right? Can we calculate the change of energy with this particular equation? Can we calculate the change in energy, right? Yes, we can calculate. We can calculate for E1, then N will change. For E2, N will change, right? According to that, you can calculate this. So this is also true. In the case of electrons carries more negative energy. In case of, I think the question is incomplete. This means that, let's look at this statement. This means that the electron is more loosely bound in the smallest allowed orbit. See, less is the value of n. Actually, they are saying that why there is negative energy. Why there is negative energy here, right? Is it because more closer to the nucleus, less will be the energy? Are they saying that the orbits that are closer to the nucleus are less bound to the nucleus? No, that is not true, right? So electron which are closer to the nucleus, right, they have more negative energy, right? That is the reason. Now what it symbolizes, that closer to the nucleus means they are more bounded to the nucleus, right? Closer to the nucleus means more attraction with the nucleus. Away from the nucleus will be less interaction. So closer to the nucleus, loosely bound in the smallest? No. Closer to the nucleus, more closer, and an electron is to the nucleus, more attractions will be there. So this is false. That the energy of electrons which are attracted to the nucleus will be smaller, then that would be electrons were at infinite distance from the nucleus. This is the meaning of the negative sign. Now they are saying, is the meaning of negative sign that the energy of electron which are attracted to the nucleus will be smaller than that would be if the electrons were at infinite distance. Yes, if they would have been at infinite distance. See, what exactly is happening here? For this now, I need to teach you this thing about energy. Okay? I need to teach you this thing about energy. That if you follow this particular thing, this is n is equals to 1, right? This is n is equals to 2. Okay, it will be somewhat here, right? This is n is equals to 3. This is n is equals to 4. This is n is equals to 5. And so on is your infinity. And so on is infinity, right? So what we observed here, this is n is equals to 1, this is n is equals to 2, this is n is equals to 3, n is equals to 4, n is equals to 5. What is happening here, if you see this, it is inversely proportional to n. So if I talk about, let's say, electron volt, it is minus 13.6. If Z I am talking about only, let's say, hydrogen atom. Okay, I am only talking about hydrogen atom. Right, I am making some conclusions here. Okay, so only if you talk about hydrogen atom, what you will see here, minus 13.6, Z is 1. See, for hydrogen atom, Z is 1. So it will be minus 13.6 by n square is going to be the value of energy. N is 1, this will minus 13.6. Here it is minus 13.6 divided by 2 square, right? That is divided by 4. That is going to be, wait a minute. Let me precisely calculate it. By 3.4. Now you will see the gap is going to decrease. Wait a minute. I have drawn it wrong. Right? It will be actually like this. Okay? Yes. Okay? Now, this is going to be n is equals to 2, this is n is equals to 3, this is n is equals to 4, and n is equals to 5, and so on. Okay? So, here it is minus 13.6, that is minus 3.4. Right? Okay? What about the next one? This is going to be minus 3.4. Wait a minute. Divided by, this is 3 square is 9. Right? So if I say 13.6 divided by 9, it is going to be minus 1.51. Okay? Now, if I say 13.6 divided by 60, that is going to be minus 0.85. Now, do you know why I am dividing it by 16? Because for n is equals to 4, it will be 4 square, that is 8. 4 square, that is 16. So that's why I divided it. Now, you can take it, then n is equals to infinity and so on, so on, so on, so on. That is your n is equals to infinity. Now, can you see a difference here? This is exact calculations, right? Now you can remember this, but I would not suggest you that much to remember how much you can cram in life, right? how much do you need to cram. So I will not suggest you. Just remember one thing. Can you see the difference is increasing? In fact, this is not even the correct thing. This is actually the correct thing. Okay. Can you see that the difference is increasing here? Right? Can you see that? N is equals to 1 is minus 13.6. Then as n is increasing, can you see energy is going in the positive direction? As n is increasing, energy is increasing. This is minus 13.6. This is minus 3.4. This is going to move towards 0. Right? On the number line, you can see that as n is increasing, the energy is increasing. I am talking with sign. Okay. So, can we say that as n is increasing, delta E, that means the change is decreasing? Can you see that? The change is becoming less, right? Okay. So this is what we want to say here, right? That when you go beyond a certain point, let's say at n is equals to infinity, energy is going to be 0, right? For that electron, because n will become infinity here, right? So that you must remember, this I am talking about with negative sign. I am not talking about with, if you talk about only the magnitude point, this will decrease. The magnitude of energy is decreasing. Okay, I am talking with the negative sign, right? So this is what they are saying here, that the energy of the electron which are attracted to the nucleus will be smaller, right? Then it would be if electrons were at infinite distance from the nucleus. This means that negative sign in the equation, right? This is the meaning of the negative sign, right? That as you go to infinite distance, the energy is going to increase, right? Okay, and the distance in the energy is going to decrease. The distance in the, that's why we draw it like this. Maximum, then distance is less, then even less, then even less, and it will start be colliding with each other, right? Okay. Yes, everybody. Clear now? Now, second postulate, right? That is, energy of the electron in the orbit does not change with time. With time, it's not changing. It can move from lower stationary state to higher, or from higher to lower. Now, how does it do that? Now, if you remember in Rydberg model, there was a point that if electron is accelerating, then it will lose energy and it will fall into the nucleus. Why this does not happen is because they have fixed, like you have to stay here. And if you want to go to some other orbit, you have to give money for that, right? So in the same way, like you will all have your ranks. Okay, so according to the ranks only, you will get admission in the MBBS, or on the basis of money, right? You will get admission in the MBBS, right? So that depends, private or government college, right? So in the similar way, if let's say an electron is actually now trying to move from higher to lower, okay? Higher to lower if it is going. So we know that as n increases, energy also increases. Let's say this is E2 and let's say this is E1. This is energy of, let's say, first orbit. Let's say it is moving from this En, let's say here E2 only. This is, let's say, E1. It is moving from some higher orbit to some lower orbit. Now, when it is moving from higher orbit to energy of lower orbit, right? Now, we know that, let's say, in the higher orbit, it has to have 1000 energy. Here, it needs to have 800 energy. Now, what it will lose? What it will do? It will try to lose the energy. It's the same example. Let's say you are going to a movie theater. Okay. In one movie theater, it's very expensive. It's 1000. In other movie theater, let's say it is 500. Okay. So now you were thinking, firstly, what you did, you were thinking of going to this theater. Now you're thinking that not to this theater, I will go to this theater where the fees is just 500. Now you will have to pay only 500. That means the other 500 you will not pay. That means that particular amount of energy you can lose, right? You can use it for some other use, right? You can do that. So here what it will do, from higher to lower, here if 1000 was needed, here if 500 is needed, it will lose the extra amount of energy that it has. Okay, I know you're thinking that, ma'am, if I have to lose that 500, I'll go to this theater only. But in electron, this doesn't happen, right? So the extra amount of energy that they have, they will lose that energy, right? So here it is 1000, here it is 500, it will lose the 500 amount of energy, right? So what will happen when the electron is going from higher to lower? What it will do? It will lose the energy, okay? Now, if the electron is going from lower to higher, what it will do? Students, I am writing just here, if it is moving from higher to lower, right, it will lose the energy, right? Now, when it is going from lower to higher, here you have 500, here you are going to move towards 1000 rupees fees. Now, you will have to add 500 here. That means you will have to absorb 500 rupees, right? So that's why we are saying that in this case, it will absorb. It will absorb. It will gain that amount of energy. Okay, it will not lose, it will gain. Here it will lose, or we can also say it will release. Understood now? From higher to lower, what is happening? From 1000 rupees to 500 you are coming. So that means you have to lose 500 rupees. Here you are coming from 500 to 1000, lower to higher, lower to higher. So you have to absorb the extra amount of energy. This is what happens here. Okay, everybody, right? Clear? Now, let's talk about Bohr frequency rule. Bohr frequency rule is simple. We know that delta E is equals to h mu. So mu is nothing but delta E by hc. Okay, mu is nothing but delta E by hc, or you can say yes. Okay, you can just simply write here delta, no, it's not hc, it will be h. Okay, it will be h. Delta E by h, right? But you can also say mu is nothing but c by lambda. Mu is nothing but c by lambda. No. C is equals to mu lambda. So mu will be c by lambda. Yes. C by lambda. So it will be delta E is equals to h. So you can say 1 by lambda is equals to delta E by hc. So this is what they are saying about frequency rule. Okay. Right, everybody? So where E1 and E2 are the energies, what is this delta E? This delta E is nothing but E2 minus E1, right? Higher and lower energy. If you want to see that if it is going from, let's say, it is moving from this energy orbit to this energy orbit. This is E1 and this is E2. Okay? So how much energy it requires? Okay? Like here we discussed, right, that here it needs it will release 500 rupees, right? Here it will require 500 rupees. How I calculated this? By making the difference here, right? So in the similar way, here also we are doing the same. E2 will have some energy, E1 will have some energy. The difference that it will have to pay that difference. Okay? Understood? So how much energy is required or released here, that is what we talk about in Bohr frequency rule. Okay? From one state to other state, how much energy is required here? Understood, everybody? Yes. Now let's talk about Bohr angular momentum. It says that Bohr angular momentum is equals to nh by 2 pi. Okay? That is, Bohr angular momentum is integral multiple of, this is integral where n can be 1, 2, 3 and so on, an integral multiple of h by 2 pi. Okay, this is nothing but Bohr angular momentum. This is Bohr angular momentum, that it is integral multiple of nh by 2 pi, and it's a very, very, very important postulate. It's a very important formula, very important postulate, right? Let's talk about some questions based on this. First question is, according to Bohr model, angular momentum of an electron in third orbit is, see, angular momentum is nothing but nh by 2 pi. N is given to be 3, so it is going to be 1.5 h by pi. So answer is B is the correct answer. Isn't it easy? Isn't it easy, guys? This is your Bohr angular momentum that they are talking about, that is nh by 2 pi. So directly you can answer this. Next question based on this thing only. Let's talk about that. Here they are saying that an electron is moving in Bohr's fourth orbit, right? Electron is moving in Bohr's fourth orbit. That means n is given to be 4. Okay. De Broglie wavelength is lambda. Actually, we have not discussed about de Broglie's wavelength till now. So I'll not do this question now, right? We'll do this question in the next class. Okay. We'll discuss about de Broglie's wavelength in the next class, and then we will do this, right? This question is, we can only do once we know de Broglie's wavelength, okay? So that's what I wanted to told you, that this particular formula, they can give you relatable questions with radius and angular momentum. They can give you mixed questions of angular momentum and de Broglie's wavelength. So that we are going to talk about that. But firstly, for that, I have to complete de Broglie's wavelength, and then only I'll talk about how radius, angular momentum and de Broglie's wavelength question can be connected to each other, right? So there is a one question that was asked in, I think, NEET 2019. That is where mixing of these three formulas were there, right? So we'll talk about that. Don't worry, we are going to talk about that. But for that, I'll talk about that question in the next class. Okay, everybody? Don't worry. For that, I need to firstly tell you a few things about that. Now, let's move to the last topic of today's class, that is the Rydberg equation. Now, for Rydberg equation, what you need to understand, that 1 by lambda is equals to RH, that is Rydberg constant, Z square, 1 by N1 square by 1 minus N2 square. And this 1 by lambda is nothing but it is V bar. Is that clear, everybody? Is that clear, everybody? Right? Now, this is your Rydberg equation. Now, here what you need to understand, that this V bar is wave number. This lambda is the wavelength. RH is the Rydberg equation, Rydberg constant. Rydberg's constant. Okay? N1, N2 is the transition that it is doing from N1 to N2. That is the transition. And Z is the atomic number here. Okay, we are going to solve the questions based on this as well. Now, one very important thing. If you want to calculate V bar, to calculate V bar, put RH is equals to 109677 and answer of V bar will be in centimeter inverse. Okay? Direct trick I am telling you. If you want to calculate V bar, you will put the value RH. If you want to calculate lambda, see, we know that if you want to calculate lambda and RH are inversely proportional. So that means after calculation, you will have to solve 109677. Now, is it an easy value to solve? No, right? So that's why directly you should know what is the value of 1 by R by H. That is 192 Armstrong, right? That means you can just directly say, if you put value as 912, if you put the value as 109677, then you will get the answer of lambda or V bar in centimeter on centimeter inverse. Centimeter inverse is for V bar, centimeter obviously is for wavelength. If you put the value of 1 by RH as 912, then the value of wavelength you will calculate is in Armstrong. Now, if they ask you in the question nanometer, convert this into nanometer, picometer, meter, whatever they ask you, you can convert it there. Conversions, you can do it, right? If you like find difficult to do conversions, you can watch my lectures on conversions. Okay, everybody? Right? Yes, everyone? Yes. Now, that is the question. Okay? Now, let's solve this here. This is very, very important, where what we have is, to apply this formula, I told you Rydberg, what you have to put. Z, they will give you hydrogen, helium, lithium, what atom it is. According to that, you will have Z. Now, what is N1 and N2? That we are going to talk about. Firstly, I am going to talk about N1. N1, they can directly give you it is 1, orbit number is 1, 2, 3, 4. They can give you it is first excited state, second excited state. That also I told you. First means N is equals to 2. Second excited state means N is equals to 3. Right? Now, if they ask you that N1 is Lyman series, that means N1 is going to be 1. This whole value is for N1, this is for N2. N2, I don't know, N2 can be anything, no idea. If they are specifying Lyman series, 1. Balmer 2, Paschen 3, bracket 4, P fund 5. Lyman, Balmer, Paschen, bracket P fund. LBP, LBP, BP. Lyman, Balmer, Paschen, bracket P fund. Lyman, Balmer, Paschen, bracket P fund. 1, 2, 3, 4, 5. Okay. Now, they can say it is going from like Lyman series, they have given you hint, Balmer, they have given you hint, Paschen or bracket or P fund, right? Or they can also specify that it belongs to visible region. Now, visible region means they are saying it is Balmer series, because Balmer series is the only series which is in the visible region. So, N1 will be equals to 2. It belongs to Lyman series. Or they can say it belongs to UV region. That means they are talking about Lyman series. Right? So, they have specified this thing. Right? Okay. Infrared, they will not specify, because for infrared, you have 3 values. That's why they will not confuse you with infrared. They will give you only UV or visible. Okay, they will not say infrared. Now let's talk about what is this Lyman, Balmer, Paschen. All the lines coming from anywhere in this universe, if they are coming to n is equals to 1, that is Lyman. So all the lines that are coming towards n is equals to 1, that is Lyman. That are coming towards n is equals to 2 is Balmer. Towards n is equals to 3 is Paschen. N is equals to 4 is bracket, n is equals to 5 is P fund. Lyman, Balmer, Paschen, bracket, P fund. Lyman, Balmer, Paschen, bracket, P fund. Okay, right? 1, 2, 3, 4, 5. This visualization should be there. What is Lyman? All the lines, whether it is coming from n is equals to 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or n is equals to infinity, if it is coming towards n is equals to 1, that is Lyman. Any line coming from any N2, but it is coming towards n is equals to, that is Balmer. Okay. This lies in the UV region. This lies in the UV region. This lies in the visible region. This lies in IR. This lies in IR. This lies in IR. Rest of them, they have not specified. These are specified lines. Okay. Now, let's talk about, what about N2, ma'am? What about N2? So I told you that N2 can be anything. 2, 3, 4 infinity, 3, 4, 5 infinity, 4, 5. Because it for Balmer series, why not N2 cannot be 2? Because it is coming towards 2. So it can be 3 or 4 or 5 or 6. Right? So we know that this N2 should always be in this formula, you can write. This N2 should always be greater than N1. Okay. The line from where it is coming towards N1 should always be greater than N1. Right. Maybe it is +1, +2, +3, whatever. Now for N2 also we have some important points, right, where they can confuse you. Right. So let's talk about these points. That is, if you talk about, they gave you first line. then N2 is nothing. N2 is nothing, but it is N1 plus N2, right? First line, if they give you second line, then N2 is nothing but N1 plus 2. If they gave you third line, then N2 is nothing but N1 plus N3. Can you tell me why? See, I'll just delete this here. If I say N2 is equals to first line of Lyman series. So first line is this one. Second line is this one. This is the third line. This is the fourth line. So can I say first line is N1 plus 1. Second line is N1 is 1 na, plus 2. Third line is, this is the third line. Third line is N is equals to 4. So it is N1 plus 3. Fourth line is N1 plus 4. Right? So this is what we want to say here, that if they give you first line, if they give you first line, they give you second line. First line is N2 is equals to everybody. First line is N2 is equals to N1 plus 1. Second is N2 is equals to N2 plus 2. Third line is N2 is equals to N1 plus 3. Now can you tell me what is fourth line? Everybody, what is fourth line? N2 is equals to N1 plus 4. What is fifth line? Everybody, what is fifth line? Fifth line is N2 is equals to N1 plus 5 and so on. Right? Now, first line is also called alpha line. Second line is called as beta line. Third line has a name that is gamma line. They can say you alpha, beta, gamma. Till now, they have not asked alpha, beta, gamma line. They have not used it in the exam, but they can use it. Maybe in NEET 2026 they will use. Okay, so first line is alpha, then beta, then gamma, right? Now limiting line or last line is when N2 is equals to infinity. That is your limiting or last line. And what is this arrow representing here? This is saying that N2 is going towards N1. N2 is going towards N1, N2 to N1, N2 to N1. Now let's talk about energy, maximum energy, minimum wavelength, about this, right? So if they give you minimum energy, that means the difference in energy is minimum. So difference is minimum means they are talking about first line. Maximum difference, that means they are talking about infinity. N2 is infinity, right? So if they say that minimum energy, that means N2 will be is equals to first line, that is N2 is equals to N1 plus 1. Because minimum energy difference is here only. Maximum energy difference is in N infinity. If N is infinity, maximum energy difference will be there, right? So it is maximum energy, you have N2 is equals to infinity. Now we know that E is equals to H mu, or it is Hc by lambda. So if energy is minimum, mu is also minimum. So they can also say minimum frequency. Here they can say maximum frequency, right? Because energy is directly proportional to frequency. If they write lambda is maximum, or they can say longest, wavelength. That means they are talking about minimum energy, right? So minimum energy is this, because lambda and energy are inversely proportional. If they talk about shortest wavelength, they talk about maximum energy, that is N2 is infinity. Students, tell me if that is clear or not. N1 you will get to know from Lyman, Balmer, Paston. N2 maximum, this they can do to confuse you. Nothing beyond this. Okay? Nothing beyond this. Now let's talk about this question here, that is EIPMT 2011 question. According to the Bohr theory, which of the following transition in the hydrogen atom will give rise to least energetic photon? Everybody, least energetic photon. Everybody in the chat box. What is least energetic photon? Right? Let's talk about this. According to Bohr theory, which of the following transition in the hydrogen atom will give rise to least energetic photon? See, we know that 1 by lambda is equals to R Z square 1 by N1 square minus 1 by N2 square. And lambda and energy are inversely proportional. So if I say this should be minimum, this should be least, then this has to be this should be minimum. So this should also be minimum. Okay. If I am saying that this should be minimum, least energetic photon, give rise to a least energetic photon. That means if energy has to be minimum, then this also has to be minimum. So if I want to solve this, see, this I got from energy is inversely proportional to lambda. And lambda is nothing but this thing, right? So they are saying Z is fixed, RH is already fixed. So we can say energy is directly proportional to 1 by N1 square minus 1 by N2 square. So what I need to do is I just need to solve it here, right? Going from 6 to 1. See, when it is moving from this to this, they will lose energy, they will give rise to photon, because higher to lower, it will lose energy. So that the energy that they will lose will be in the form of photon, right? So that photon will have some energy, right? So if either they ask you least frequency, least energy, that means we are about to solve 1 by N1 square minus 1 by N2 square has to be minimum, right? For that, put in all the values. 1 by 6 square minus 1 by 1 square. This cannot be minimum because this is 36. This is going to be no. This is N1 to N2. Yes, 1 by 6 square minus 1 by 1 square, right? 36, 1 minus this, no. If you talk about 1 by 5 square minus 1 by 4 square, right? So 1 by 25 minus 1 by 16. This is 1 by 36 minus 1 by 25. This is 1 by 25 minus 1 by 9, right? So you just have to solve it, and the minimum value of this is going to be your answer, okay? Calculation, guys, you can do this yourself also. So when you will see that with this particular thing, it will give the least energetic photon, okay? Yes, everybody, with this particular equation, because if you have this is minimum, this energy is automatically going to be minimum, right? Everybody, calculations you can do it yourself, right? Okay, just LCM that you have to take, right? Okay, now this is a question. Let's see this. The shortest wavelength of hydrogen atom, they are saying the shortest wavelength of hydrogen atom in the Lyman series is lambda. Now Lyman series means N1 is given to be 1. Can I say shortest wavelength means energy will be maximum? That means N2 is going to be infinity, right? Is lambda 1. The longest wavelength means N2 will be, Balmer series is N1 is equals to 2. So N2 will be 1. See, longest means energy has to be minimum, right? Minimum energy is in the first line, that is N2 is equals to 1 plus N1. That is 1 plus 2, that is 3. Okay. Now what you have to do, you just have to solve it here, right? How do you solve it? The shortest wavelength in this case is lambda 1. In this case, it is, what is the value? Let's take this as lambda 2, right? Apply Rydberg equation. 1 by lambda 1 is equals to RH. In case of hydrogen atom, Z is 1, so it will be 1 by N1 is 1 square, N2 is infinity, right? So you can say this is RH, this is 1 minus 0. So 1 by lambda 1, that is lambda 1 is equals to 1 by RH, right? Okay, what about this one? Here what you have is 1 by lambda 2 is equals to RH. For helium, it is 2 square. It is 1 by N1 is what? N1 is 2. This is 1 by 3 square. So you just need to solve it, guys. This is nothing but, this is 1 by lambda 1, right? Sorry, this is lambda 2. RH is 1 by lambda 1. So can I write it here? 2 square means 4. And this will be 1 by 4 square. This is 1 by 1 by 4. This is 9. So you will say this is lambda 1 by lambda 2 is equals to 4. This will be 9 minus 4, 5, 6, 7, 8, 9, 5 by, this is, okay, this is how I think you are going to solve it. And you will have the relation of lambda 1 and lambda 2 here. Okay, everybody? Just give me a second. Got some urgent. Just give me a second. Okay. Okay, everybody. So, clear, right? Okay. So that's how you can solve this and you will get your answer. Now, the last topic of today's class is when they will ask you number of spectral lines. See, I'll tell you a long method and a short method also. Let's talk about the long method firstly. Long method is you have this is N1, this is N2, right? This is, let's say, N3. Let's say this is N4. This is N5, right? This is N6 and so on, right? Now, we will talk about one case, right? I'll tell you how exactly it is done. We have to calculate the number of spectral lines, okay? So, let's say they are talking about n is equals to 4 to n is equals to 1, okay? Understand this very carefully. This is n is equals to 1, this is n is equals to 2, this is n is equals to 3, n is equals to 4. This is the fourth line, okay? Fourth orbit. Now, calculate all the lines that are possible from n is equals to 4 to 1. All the lines possible. So, from 4 to 1, how many lines are possible? Okay, everybody, let's see. From 4 to 1, it is possible. Then from 4 to 2, it is possible. Then from 4 to 3, it is possible. Right? That is the first set of possibility. Then between 4 and 1, what are the other possibilities? From 4 to, directly we can say, wait a minute, right? So how many spectral lines are existing when it is coming from 4 to 1, right? No. We are talking about 4 to 2. So let's talk about this thing. Let's say, also they are talking n is equals to 1 only. So that was correct. That I firstly wrote, right? Okay, right? So there is one set of possibility that is here. What is the other set of possibility that is possible? So 4 can also jump to, it can also move like this. It can also go directly. There is also one possibility that firstly it will move from n is equals to 4 to 3. Then it will move from 3 to 2. Then it will move from 2 to 1. That is another possibility. See how it can jump from 4 to 1. One possibility is directly it will jump, right? So I'll do it this way. One possibility is it can directly jump from 4 to 1, right? Another possibility is it will go from 4 to firstly 3, then 3 to 2, then 2 to 1. Okay? This is another possibility. Another possibility is it will go from 4 to firstly 2, then 2 to 1. See, it's like you have to go from A point to B point, from your school to you are going to your tuition, right? So there's so many ways that are possible. Similar thing I am talking about. From 4 to 1, it can directly go. You can directly go from your school to your home. Let's say you can directly go and go to your home, right? Second possibility is in between. You will see something to eat. You can eat something in between. Then you can meet your friend. Then you will go to home, right? Third possibility is you will meet your friend and then you will go to your home. Another possibility is you will eat something. That means first it will go from 4 to 3. Then from 3 to 2 directly, right? Is there any other possibility that is possible? No, right? There is no other possibility that is possible, right? So it will directly go then from this to this to this, or directly here to this, or directly here to this. These are the possibilities that you have. I'll just make the arrows. So this is the first possibility. Second possibility is this one. Third possibility is this one. Fourth possibility is this one. Okay. Now eliminate the common lines here. This and this line is common, so I'll eliminate this. This line is not common between anyone. This and this line is common, so I will eliminate this one. Is there any other line which is common? Any other line? This line is unique. This line is unique. This line is unique. Right? There is no other line that is common. So we can say 1, 2, 3, 4. So number of lines, it is coming out to be 4. Okay. Now I will teach you one formula. Rather than doing this, we'll have this formula, that is n2 minus n1 into n2 minus n1 plus 1. According to this formula, it will be 4 minus 1, 4 minus 1 plus 1 divided by 2. So it is going to be 4 minus 1 is 3. It is 4. So it is 2, 2. It will be 6. Wait a minute. It should be 6. It should be 6. What line am I missing? It is going from this to this, 4 to 3. See, from the formula, it is coming out to be correct. So what missing line we have? It is going from 4 to 1 directly, then 4 to 3, 3 to 2, then 2 to 1, right? Then it can go from 4 to 2, then 2 to 1, right? Then it can go from 4 to 3. There will also some other unique line here, right? 1, 2, 3, 4, 5. There is one more. Why we are calculating the wrong one? 1, 2, 3, 4, 5. There is also one more unique line here that we are missing, right? Wait a minute. Either 4 minus 1, 4 minus 1 plus 1 divided by 2. That is going to be 3 into 4. Yes, it is going to be 6 only. What is the line that we are missing? Four to 1. Let me just see, have I taken all the possibilities? 4 can also come to 2, 4 can also come to this. 4 can directly, this is another possibility that we forgot. Okay, see, we have to see that 4 can also come to any other place. Okay, so 4 to 1 we have written, 4 to 2 possibility we have written, 4 can also directly come to this 2. This is also another possibility that is possible here, right? This is also another possibility. Let me just remake this, right? I know it's a bit confusing. That's why we have formula for this, right? This line, this I am telling you, this is, wait a minute. Okay, so what I'll do, I'll make one new format here, right? Okay, because in that way it is not possible. This is n is equals to 1, this is n is equals to 2, this is n is equals to 3, this is n is equals to 4, and I'm just writing till 4. Okay, so now we will do it again. 1, 2, 3, 4. So we are doing it for n is equals to 4 to 1. Okay, or 4 to 2, whatever you can do. Now let's calculate the number of lines that are possible here, right? Number of spectral lines. So let's see this. Number of spectral lines can be 4 can directly move to 1, right? 4 can move to 2 also. 4 can move to this also. This is the first possibility of 4 to 2, right? That 4 can directly move to 1, 4 can directly move to 2, 4 can directly move to this. I think this arrow will be much better. right? Otherwise, though, it will be little bit confusing because arrow will tell you what is there, right? 4 to 1, 4 to 2, 4 to 3. These are the possibilities. Then next set of possibilities that 4 can firstly move to directly to uh, 4 can firstly move to 2, then 3 to 2, then you will have 2 to 1. This is another set of possibility. Another set of possibilities that we can have, firstly we can have 4 directly to 2, right? Okay, then we can 4 directly to 2, then 2 to 1 it can be, right? Another set of possibilities, I know it's quite confusing, I know that, right? Another set of possibilities, 4 can travel from this to this, then it can move directly to from this to this. This is another set of possibility. See, if you see this here, these are the major possibilities that you have. Okay. So what I am telling you, all the number of spectral lines that are possible here. Possibilities 4 to 1. See, one thing is directly 4 is moving towards 1, or 4 to 2, or 4 to 3. That is one set of possibility. Another set is it has to travel from 4 to 1. It can go 4 to 3, 3 to 2, 2 to 1. It can also travel like 4 to 2, then 2 to 1. It can also go like 4 to 3, then 3 to 1. These are the maximum possibilities that are there, right? Now you will see, eliminate the common ones. So what is the common ones? Let's eliminate that. So this and this is common. So I will eliminate 2 of them because common possibilities we can't say. This is 4 to 2. This is also 4 to 2. So let's eliminate this one. This is 4 to 1. Any other 4 to 1? No. This, both of them are 2 to 1. Okay, let's eliminate this one. Okay. Now 4 to 3 you have one possibility. 4 to 2 you have one possibility. 4 to 1 you have only one. Then you have 2 to 1. Then you have 3 to 2. Then you have 3 to 1 also. So these are the some unique lines that are possible. So 1, 2, 3, 4, 5, 6. So total spectral lines here possible are 6. Can you see that? Total spectral lines possible here are 6. Can I see that here? Right? Total spectral lines possible are 6. So, would you do this here? It is only 4 to 1. Okay? If they ask you n is equals to 6 to 1 or 6 to 2, would you want to do this in the exam? See, this is actually a very, very irritating thing to do in the exam, right? So that's why this, I just told you this because I wanted to tell you that this is difficult to do, right? Because, it's like permutations and combinations. Easily you can do mistakes here, right? Easily mistakes are possible because some set we tend to forget things, right? So it's not like every possibility you can make, especially if there is a large number of spectral lines that can be there, right? So for that, we have this direct relation, that is n2 minus n1, n2 minus n1 plus 1 by 2, right? So when you solve it this way, it will be n2 minus n1, n2 minus n1 plus 1 divided by 2. When you solve it this way, the answer is going to be 6 lines only. So answer, when you do this in the exam, it is very simple, right? Just put the formula, you will get your answer. That's it. Now, what is this? Number of specific lines, number of specific spectral lines. This is the reason I taught you this whole thing. Now, students, if they ask you something specific, whenever they ask you specific, what do you mean by that? Anybody? Specific. This is where students tend to do mistakes, because specific means if they ask you, it is moving from n is equals to 4 to 1, tell the lines that lie in Lyman series. That means you have to only tell the lines, unique lines that are moving, that are only coming towards n is equals to 1. You say, ma'am, 4 lines here. No. To n is equals to 1, how many lines you have here? See, we know that this and this is common, right? This is unique, this is unique, this is unique. So to n is equals to 1, you have only 3 lines between 4 and 1 that are falling on n is equals to 1. That means in Lyman series, you have only 3 lines. Okay. Now, they say that belonging to Balmer series, they will say from 4 is equals to 1, 4 to 1. This is the pattern of set of lines that you have. In these 4 to 1, you have total 6 lines. Out of these 6 lines, 3 lines are belonging to Lyman series. Okay. So specific means they are asking you which is belonging to Lyman. Now tell me which is belonging to Balmer. Balmer means n is equals to 2. So this, and this. We know that these two are common, so this will be eliminated. Common lines we don't take. This is also 4 to 2. This is also 4 to 2. So now this and these are the 2 lines that are belonging to Balmer. So you can say 2 lines will be belonging to Balmer. Okay. Now, can you see there is only this, and this is the same line. So we will eliminate this and eliminate this. To Paschen, you have only 1 line that is belonging to Paschen. Right? Okay. Paschen, you have 1 line. So specific line means out of these 6 spectral lines, how many are belonging to Lyman, to Balmer, to Paschen? Okay. One way is to draw it and then to tell which is belonging to Lyman, Balmer, just like I showed you that these are the common lines 4 to 3, 4 to 3, 4 to 3. So we will take only one, that is 4 to 3, right? Because we are considering the type of spectral lines, right? So 4 to 1, we have one kind of line. So either you draw this full thing and then you answer. Now those students who are able to understand this, that's good for you. Your concept clarity will be there, right? But if you're not able to understand that, it's okay, right? I'll give you a simple trick. If you're not able to understand that, it's okay. What you can do is, right, directly do high minus specific. Now, if they ask you out of n is equals to 4 to 1, which are Lyman, which are belonging to Lyman. So we know that high is 4. This is high to low. High is 4. It will be 4 minus Lyman is 1, so it is 3. Balmer, what is the answer? For Balmer, what is the answer? 4 minus 2. That is, no, Balmer is 2, yes. Paschen, what is the answer? High to low. High is 4. Paschen, n value is 3. So it will be 1. So out of these 6 lines, you can directly say high to specific. Specific means are they talking about Lyman or Balmer or Paschen, right? Okay, everybody understood? Yes. So this is what we will do here. So let's say, students, again, I am telling you, I know that you have problem in this. If you are feeling, so I know that some students find it very difficult to understand this thing. See, here what I did is, I made all the possibilities. Then I told you without formula how it is done. Okay. But see, without formula, it is very time consuming. Easily you can do silly mistakes in the exam. That's why even if you're not able to understand how to calculate it from the diagram, it's okay. It's fine. Because this is not what we are going to do. This I just told you why this formula is like this. Okay. So to make it easy, this is the right formula to calculate number of spectral lines that are falling from N2 to N1, right? You can just put N2 minus N1, N2 minus N1 plus 1 by 2. Or specific if they are saying out of this N2 to N1, which are belonging to Lyman, which are belonging to Balmer, which are belonging to Paschen. So this will be higher minus specific. Higher is N2, higher is nothing but that is N2. This is specific. Whether we are talking about Lyman, Balmer, Paschen, that you will put here. Directly you will have your answer. Okay. Now let's do the question here. An electron jumps from, you will tell me what they are asking you. Are they asking you specific or general spectral lines? In an electron jumps from 6th energy level to 3rd. That means it is going from 6 to 3. Okay. N2 is 6, N1 is 3. Level in the hydrogen atom, how many lines belong to visible region? Now, they are specially asking, they are not saying calculate all the lines of n is equals to 2 to 1. So all spectral lines, if they ask you number of spectral lines, if they ask you, if they don't write this, if they just write how many lines belong to n is equals to 6 to n is equals to 3 transition, then it will be number of line is 6 minus 3, 6 minus 3 plus 1 by 2. That is 3, 3 plus 1 by 2, that is 3 into 4 by 2, that is nothing but 6. Okay? n2 minus n1, n2 minus n1 plus 1, 3, 3, 4, 4, no, 4, 4 by 2, 2. Okay. Yes? Okay, everybody? Now, let's talk about this one. Yes. Okay, that is the case. Now, let's see number of specific. Can you tell me specific lines is what? Specific, they have, what is the specific orbit that lies in the visible region? So now they have not asked you number of lines. They are saying specific. What is this specific? Specific is visible. Visible is what, guys? What is visible? Lyman Balmer, right? Lyman lies in UV. This means they are talking about Balmer region. Balmer region. So Balmer region is nothing but n specific will be 2. Now tell me, this is 6, this is 3. You are calculating the lines from 6 to 3. Logically tell me this thing. If the barrier is 6 to 3, then the number of lines will be between this only. And they are asking you which line will fall in n is equals to 2. If they are saying between 6 to 3, there will be 6 lines. But these 6 lines will be under this barrier. So n is equals to 2, there will be 0 line because they are not asking between this barrier. So between all the 6 lines are belonging to this barrier. No line in this barrier is coming towards n is equals to 2, right? So here answer is going to be 0 is the correct answer. You don't even need to apply the formula. It's not possible only, right? Okay? Understood, everyone? Now, let's say they ask you, the same question, right? Let's say they ask you the same question, but they are asking now that this is belonging to specific line for, they are saying specific line belong to, let's say, Paschen. To Paschen, with what it is belonging. To Paschen, especially to Paschen series, how many lines you have? So out of this 6 line, what is belonging to Paschen? So that means n specific is going to be 3. So number of Paschen lines, that is going to be high is 6 minus Paschen is 3, it is going to be 3. That means out of this 6 lines, 3 will lie in the Paschen. Okay? Out of these 6 lines, 3 will be belonging to Paschen. Okay, everybody? Got it? Yes, everyone? Right? Now, next is the third line in the Balmer series corresponds to an electronic transition between which Bohr orbit in the hydrogen atom. See, third line in the Balmer series. We know that Balmer is nothing but n is equals to 2. If this is n is equals to 2, this is 1, this is 2. Here it is 3, 4, 5, 6. So first line will be this, second line will be this, third line will be this. Okay? So this is 3, 4, 5. That means third line is belonging to 5 to 2. So answer will be 5 to 2 is the correct answer. So for this, imagination is needed. You should know about the lines. What is first line? What is second line? What is third line? And I told you already that third line will be 3 plus n1. That is nothing but 3 plus n1 is what? 2. So answer will be 5. So this is from n2 to n1. So it will be from 5 to 2. If they ask you gamma line, to make this complicated, they can ask you here instead of third line, they can say gamma line. Okay? That also you can answer. Gamma is the third line. Okay, everyone. So that's it for today. And these are the limitations of Bohr model, that it is just applicable for single electron system. It is not applicable to multi-electrode system. It was not able to explain the doublet and triplet. See, in the peaks you have doublet, you have triplets, right? That we will see in NMR spectroscopy, that is there in like masters, not here. So these doublets and triplets in NMR spectroscopy, he was not able to explain. What is NMR spectroscopy? That you don't need to know, right? Then unable to explain Zeeman and Stark effect. Now Zeeman effect is that in the presence of magnetic field, they were splitting into the different lines. So he was not able to explain it. Stark effect. In the presence of electric field, the lines were getting splitted. He was not able to explain it. So all these definitions you should know, that what is the definition. Then could not explain why there is need for atom to make, when atom is stable, why it is getting bonded with each other, why it is doing these kind of reactions, why there is need to form covalent or ionic these kind of bonds. So he was not able to explain that. Could not explain dual nature of matter and Hinsberg uncertainty principle, that we'll talk about in the next lecture about the duality. So this limitation will be best understood once we go through de Broglie equation, Heisenberg uncertainty principle. Then I'll tell you why Bohr model failed with respect to Heisenberg and duality, right? Okay, because he only considered electron to be at discrete points. Okay, he didn't consider dual nature, he considered that they are quantized. Okay, that's what he considered, right? So guys, this is your homework question of NEET 2019 question. I want all of you to write it down in the comment section, the homework question, right? And take a screenshot of this, everybody. Take a screenshot, everyone. Take a screenshot of this question, right? And guys, this is our Telegram channel for Vedantu NEET English, right? And here we have, right, this is DNA NEET 2026 batch. Guys, this particular batch is for all the students who are droppers and in 12th class. So students, in this batch, that is just at 4999, live classes are going on. Replay version also, we provide you the doubt solutions in the replay version as well. You can ask your doubts. And then guys, in the classes itself, quizzes, leaderboard, everything is there within the class. And after the class as well, DPPs will be provided, Tattva modules will be given, mock test will be taken after every 15 days, what we have covered in that 15 days. And then test series will be provided, right? So all of this is provided at just 4999. You can go and view the course plan here, right? If you want NEET quick revision cards, like these quick revision cards, and all India test series hard copy delivered at your home, that is for 7999. If you want Tattva module, see, Tattva module will be provided in these two cases as well, but that is PDF form. But if you want the books to be delivered at your home, then that is at 10,999. So according to what you need, you can choose the plan. Okay? Yes, everybody? Okay. So guys, that's it for today, and I'll see you all in the next class, right? And please solve the questions regarding Bohr atomic model. It's a very, very important topic, right? Okay, sure. Okay then guys, I'll be waiting for your homework in the comment section. Till then, bye-bye. Take care. See you all in the next class. Bye-bye.